Hey everyone, good morning, good afternoon, and good evening to all who all are joining us globally. Hope you all are doing well. I am Parth Varu, event planner for Microsoft Reactor India, and I welcome you to Tech Espresso, where Dixit will gonna attend the session. So, before we begin the session, let's go through our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in a way you all engage. And yes, obviously, we do encourage you all to participate. So please drop all your questions in the chat section. And now, would like to bring in Dixit, who is the speaker for our today's session. Hey Dixit, how are you doing?
Hey, good morning, Path. All good, Parat. All good.
So what do we have today?
So today we are going to discuss about the how the startups can uh, obviously they are using in the everyday world. When we engage with startups, everybody is now moving towards the containerization. So we thought that let's bring the some baseline structures that the startup can use while designing their solutions or the architectures on the AKS cluster. So today we are going to discuss about how they can use the baseline configuration of the AKS clusters and the various uh, good and the best recommendations that they can leverage in their solutions.
Sounds good. It's like learn AKS from the scratch.
Yes, we can correlate to that.
Okay, cool. So Dixit, over to you to begin the session.
Sure, Parth. Shall we start, Parth, or do we need to wait for a couple of minutes more?
We can start. We can start the session. Not a problem.
Okay, sure. Thank you. Good day, everyone. Just a brief intro about me. My name is Dixit Arora. I worked in Microsoft, working in the DNISV Center of Excellence team. Day-to-day work uh, went with working with startup, ISV, and the digital native accounts that we have across the industries. So today, as we are discussing initially, that we are going to discuss about the how you can uh, baseline the AKS cluster configurations and what are the best recommendations and the techniques that you can leverage while deploying your solutions on the AKS clusters. One thing we just to call out that obviously we are going to discuss about the best practices and the various recommendation techniques or the guidelines from the AKS cluster perspective. I'm assuming that we are uh, having the basic level of the AKS knowledge. You are already using that AKS configuration and you are already using that AKS service from the Azure side, and you are already running your application or solution on the AKS. And on top of that, what all things as a startup, what all things as a customer we can do so that we can make our solutions and make the best use of the AKS service from the Azure side. So obviously just the couple of call outs from this particular session, that it is not the introduction to the Kubernetes, as we calling out that we are assuming that you already worked or you are already working on the AKS. You have already deploying your application on the AKS. On top of that, what are all the recommended and the best practices that we can pitch in the AKS, so that from every particular perspective, from the architectural perspective, from the scalability perspective, what all things we can add so that we can, whatever application we are running on the AKS will have the desired results that you're looking for. So first of all, obviously, as we are discussing about the AKS deployment and the AKS cluster configuration, what are all the configurations that we can have in the AKS clusters? So the first question would be how you are doing the deployment. So as the first party service from the Azure sides, um, we do have um, you can say two modes by which you can able to deploy Azure services, which is called the ARM templates and the biceps. And the other approach that many customers are using, uh, uh, probably whether it be at startup or any stage, they are using Terraforms. So Coming to the biceps, as it is the first native, the first uh, hand service of the Azure, so obviously it will have the you can say all the features, or probably the upcoming features which are released uh, to the infrastructure as a code approach will be come to as a bicep, and then probably the other open source things will able to leverage those. But yes, you are absolutely free to use the Terraform scripts as well, as they are cloud agnostic, and it does not make you uh, you can say applicable or stickiness to the one Azure cloud provider. So uh, you can use Terraform, and able to make your solution cloud agnostic. So coming to the bicep part, as many of you probably might work on the ARM templates before switching to the bicep. So ARM template is more on the JSON kind of a notation that we use in the ARM templates to deploy resources in the Azure. And biceps is more on the, you can say, it's more kind of a easier syntax kind of a language. If we can say it's more like the C sharp language. You can declare variables, you can declare parameters, you can loop around. So more like the world that probably uh, you can correlate to the to the C sharp world. So bicep is more user friendly, or you can say it is more easy as compared to the ARM templates that we generally have in the previous era. But yes, both can be used, or we can say even the Terraforms can be used to make it cloud agnostic, so that you have that particular script and it can work across all the cloud providers with little bit code changes. So I have those particular scripts with me. I can share it at the end of this session. So we do have the bicep scripts as well. We do have the Terraform scripts as well. So if we go about the scripting part, so let me go through the biceps templates that we have, and at the end of the session I will share the GitHub repo that you can refer for the Terraform scripts and for the bicep scripts that we are going to discuss. So coming to the bicep template that we have. So in the bicep template, we do have the parameters file, and we do have the another uh, the main bicep files, or let's say the module based uh, biceps file, which you can call as per your business terms. In this parameters file, parameter.json file, we define that what are the Kubernetes uh, uh, version that we are going to use. If we switch to the main bicep file, so we are declaring the variables and the parameters. So these are the parameters that we have. And if we scroll down, that we are defining the what would be the cluster name, what would be the network plugin that we are using, what would be the network policy that we are going to use, the load balancer type, the outbound type, all those particular things. So even if we go about the user node pools, we mention about the particular configuration that we are going to use for this particular AKS cluster deployment. So more like the you can say the native uh, C sharp kind of a home thing that uh, you will be able to use by declaring the variables, by declaring the parameters that we have, and then assigning those values in your scripts. Same thing for the networking module that we have, and same thing we have for the AKS cluster, specifically for the AKS clusters. So same thing, we are defining the node pools, um, having uh, uh, the looping around those that we have defined, some things on the network profile as well, and then some configurations on the node pool sides. Switching back to deck. Before that, any questions from anybody? Okay, let's move on then. So, uh, today's we are going to discuss about the cluster baseline. Now when we talked about the AKS cluster baseline, uh, I have segregated into four components. First one is the compute and the infrastructure part. The second one is the process thing. Third one is the networking option, and fourth one is the observability. Now, when we talked about the compute and the infrastructure part, there are a couple of things we need to make sure that um, we choose manage identity. So we will discuss why we have choose manage identity over the service principles. We choose uptime SLA in comparison to the free uh, you can say the API version of the Kubernetes. Uh, we prefer both system pool and user node pools. We will discuss why we have chosen that. Again, on the process side, the ACR integrations. So what is the plan you can take while upgrading your application, while upgrading your clusters, all those particular things, basically while upgrading your uh, or making a new version deployment to the AKS clusters. How Azure AD and RBAC things come into the picture. What are the authentication and authorization things that you can have on the networking sides? We prefer Azure CNI. We will discuss why we have why we have choose Azure CNI over the kubenet, the network policies with the Calico, and on the extreme right we have the container monitoring and the log analytics. So moving on, deployment overview that we have given, uh, the compute and the infrastructure managed identity. Now, when we create the AKS clusters, so for every AKS clusters to work with the, let's say, Azure load balancer or the manage disk, they need access to those resources, and for that particular access they need some kind of a identity. Now that particular identity can be by the can be done by the manage entity or by the service principals. So we do prefer manage entity because it will take the away of take the work from you, uh, that you need to auto create that particular secrets, the rotations that you need to perform in the case of service principles. It is basically the wrapper around the service principle. But in the case of service principles, uh, obviously, you need to perform those steps of creating the application in the Azure AD, creating the secret, creating the key, doing those all that particular workflow. But in the case of manage identity, as it is the wrapper around the surface principle, so it is also the same life cycle in comparison to the service that you are using. For example, in this particular case, as we are baselining the AKS cluster configurations, when you delete the AKS clusters, uh, the manage identity that you have created will also be auto deleted in the case when you delete the AKS clusters. But in the case of service principles, even if let's say you delete the AKS clusters, the service principle will remain will be there. So you need to go manually, and you need to make sure that you are also deleting the service principle that you have created for the use of the AKS clusters. So in short, managed identity will make more sense, as it reduce the overhead, and will take care of all the manual overhead that you need to manage, or that you need to do while managing the service principles, while creating that particular access from the AKS clusters to the Azure load balancer or to the managed disks. Moving on, so obviously why we have choose manage identity over the service principles, as we are saying that in the case of traditional approach, in the case of service principles, the client ID and the secret ID are exposed to the creators and the consumer of that particular service principles. So there is uh, at least uh, the couple of you can say uh, the admins, or let's say the couple of people who know that particular client ID and can and the secret, who are consuming that particular service principles. So in one way or the other, those can be misused, or probably uh, uh, can exploit those secrets while accessing those AKS. So to have those particular things auto rotate, and to have those things that it should not be exploited, we prefer to have the managed identity in the case of AKS clusters in comparison to the service principals. Moving on to the uptime SLA. So couple of years back, when we released the AKS service, we give the free version of the Kubernetes API servers, and it is totally free of cost. So we are only charging for the compute that you are using, that the customers are using, but we are not charging for the Kubernetes API servers or the Kubernetes servers that we are putting it in the system nodes or into the master nodes. So but certain customers have given those uh, recommendations or the suggestions that for the compliance regions as well, that they need to have certain um, SLA filled agreement with the Microsoft, that they can probably show to their compliance auditors that these are also well under the compliance SLA things with the Microsoft. So on those lines, with very little cost, we have made those the Kubernetes API servers tracked under the uptime SLA. And even now, so that um, even from the compliance perspective, or let's say from the audit perspective, if you need those things, there is a way to achieve that, and there is a way to have those things pass on to the particular business requirement that they are looking for. uh, the other thing is that it is very low cost, and it is based on the number of clusters, not on the cluster size that we have. So uh, if you are going with the free uh, free version, not with the uptime SLA, the availability percent, uh, the range will vary. For example, in this particular case, it is 99.95%. In the free version, it is 99.9. And if you go by the availability zones, then it becomes the four nines, 99.99. So those are the things that you need to make sure that when you are creating the AKS cluster, the AKS cluster. So these are the things that you need to make sure that you have the uptime SLA even for the Kubernetes based API server as well, rather than only for the workloads that you have created for running the applications. Moving on to the node pools. Uh, so in Kubernetes clusters, we do have two node pools, system node pools and the user node pools. The system node pools are used for running the core Kubernetes functionality, for example, the core DNS or the metric servers. And the user node pools are used to running the applications that the customers will deploy on the Kubernetes clusters. Now, first of all, in the case of node pools, uh, you can create depending upon the upper limit that we have, you can able to group a particular or the similar size of the VM series in one particular node pool. For example, if I create 10 node pools, I can put one particular type of series in one in node pool one, the another type of series in the node pool two, and so on. For example, and GPU based series in the case of node pool 10. So depending upon your business requirement, let's say if I want to run certain application workloads on the GPU based uh, compute, so I can create that particular node pools which will only create the GPU based series, and I'm able to make sure that I will apply the taints and the tolerance, so that the pods who are looking for GPU based intensive workload will only be able to schedule on those nodes, rather than any other work or any other pods can be run on those node pools, GPU based node pools. So why do we need it? What is the need for it? Obviously, it will optimize the compute needs. Obviously, if you don't need the um, as in the case of we discussed about the GPU based intensive node pools. So if you don't need the GPU based intensive node pools, in the other node pools, you can run on the lower configurations. Your dev and test teams uh, can run on the lower configuration, so obviously it will save cost. Also, In the case of node pools, you will be able to update one node pool at a time. So it can't be a so it can also be the case that in the case of rolling updates, when you're plan to update the AKS clusters configurations, you can make sure that you are putting you are choosing a plan which will have the updates only one particular node pool rather than every node pool simultaneously. So obviously it will help you for the rolling updates for the node pools. In the case of it also help you in the case of blue green node pools deployment. And by creating those node pools, you also have those the isolations in between, the you can say the complete physical isolations, if you want to isolate certain workloads. Also, this one is the physical isolation. Obviously, if you want to achieve the logical isolations, you can always go with the namespace concepts that we have in the AKS clusters. So coming more on the node pool side, so obviously as we are discussing, let's say as system node pools are running are mostly used uh, for running the core component of the Kubernetes cluster, for example, core DNS API metrics. So you need to have by default when you create the AKS clusters, it will have one system node pool by default with one uh, with with one node at least. You can also able to put the application or the pods running your application on the system node pools as well. That is totally up to you, but it is always recommended that you can probably segregate the core, the important part of the Kubernetes, the core part, for example, the core DNS and the AP metrics on the system node pools, and the other application workloads which is responsible for for running your application on the system on the user node pools. So on the same lines, if you want to have uh, a strict differentiation or a complete differentiation, that on the system node pools only the core components will none, the application pods will not able to schedule on those nodes. You can probably have those labels and taints and tolerates uh, uh, use collectively to making sure that no application pods will able to schedule or run on the system node pools. So for example, for one particular case, if you have the taints critical add-on only is equal to true with no schedules, it is making sure that only the core components of the Kubernetes cluster will able to schedule or run on the system node pools rather than the application pods on the system uh, node pools. The other configurations, the other call out in this particular case is that mm, that the node pools cannot span across virtual networks, but yes, it can span across subnets within the virtual networks. So whenever you are creating those node pools, whenever you are creating those system node pools or user node pools, please make sure that it is always recommended that you use both uh, system node pools and the uh, user node pools for running your applications. So I take a pause and we'll see if there are any questions at this particular time.
Hey Dixit, I see no questions yet. We can go ahead with the session.
Sure. Thank you. Moving on to part. So what would be the ideal way to upgrade the AKS cluster? So obviously if we are working in the lower environments, if we are working in the dev or test environments, you can probably roll out everything at once. When we say everything at once, changing the Kubernetes clusters, uh, deploy the node pools as upgrade the node pools as well, and even the control plane as well. But those things uh, obviously we will not be able to deploy everything at once, or it is not recommended. I can put in that words, that it is not recommended to put everything or deploy everything or upgrade everything at one go in the production environment running the AKS clusters. So what we can do, for example, if we are moving from the major minor releases from the Kubernetes version, for example 1.7 to 1.8, all those particular things. So we need to make sure that we cover every minor release that come in between the major releases. One way is to go with the first update only the Kubernetes, the version that we have. Once that is done, then move on to the node pool images. And even under the node pool images, or the node pool, make sure that we do the are we doing the specific node pool files, or are we doing all node pools? So as a business, as a solution architect, we need to make sure that whatever upgrade strategy we are making, we need to make sure that at the end of the day, it should not impact the customer experience. It should not impact the application running on the AKS clusters. So the recommended way is to go with the uh, in a batches. Uh, Pick those uh, specific node pools. Pick those control planes only. Don't go with the entire upgrades when you're rolling out the update. Uh, on the same lines, for example, um, in the case of upgrade, we do have uh, uh, the concept of maximum surge. For example, by default, it it stay with the number of 33%, or let's say the one. It can also take the value of percentage value. It can also take the integer value. So when we have the 33%, or when we take the integer value, we are making sure that we are taking one node at a time, and upgrade that particular node, and then moving on to the next one by keeping the extra node to the buffer. So in this particular case, obviously, the the time taken would be more, as we are taking spinning up the new node, and then taking the one node at a time and doing the update, and then moving on to the another one. So we can increase that particular percentage number, or the integer number in the max search. But obviously, you need to take a trade off, that what is the balance that you're looking for. That, for example, if in my AKS cluster, if I have 10 nodes pool, I can make sure that out of those 10, 7 or 8, or let's say 6 or 7 will keep serving the traffic, and I can put the upgrades on the remaining 2 or 3 that I have. So in this particular way, your upgrading will also become faster, and from the user's perspective, they will not face any disruptions from accessing the applications. And on the same lines, obviously, it will also make more sense in the case of blue green deployment that we have. Moving on to the ACR integration parts and the management, on the process side. So obviously, in the AKS clusters, we do have pods in the container, and the images are we are running that particular images. And obviously, before running that images in the Kubernetes cluster in the form of pods and containers, we do have some storage, some kind of a repository for those images. In the Azure terminology, we those are called, we can store those images in the Azure Container Registry. But there are uh, uh, other registries that you can make, or that you can leverage for storing those container images. Uh, the recommended practice from the AKS standpoint of view is, go with the uh, uh, first party services, which is Azure Container Registries, as we do have the integrations available from the Azure Container Registry to the AKS. And as we are putting images, or the images in the ACR, we do have certain tools. Uh, I purposefully explicitly mentioned the third party tools, so that we can also make sure that we also have the third party integrations with the ACRs to scan those images. So we need to so the tools available are called Aquasec and the Twistlock. So these are the third party open source tools. which you can use to scan the images that you have stored in the Azure Container Registry. One of the other recommended practices that we need to make sure that at least for the prod environment, you need to have the separate ACR for the separate AKS clusters. So obviously, uh, you can put everything or anything in the dev and the test environment, but when we are talking about the prod environment, we need to make sure that we have the specific uh, the specific RBAC, the specific authorization authentication rules in place, so that only the prod AKS clusters will able to uh, pull images from the prod ACR environment, rather than any AKS clusters in your subscription or in your environment can able to pull images from the prod ACR container registry. So please make sure that we have the separate ACR registry and we have the separate AKS clusters, at least for the prod environment. The environments, the other environments can be the mix of both, but at least for the prod, please make sure that we have the independent one. And again, coming on the same lines for the authentication and the authorization, so even in this particular case, we prefer managed identity over the service principles, and we also discuss in the initial as well that why we are choosing the managed identity over the service principles. So these are the couple of screenshots that I put, uh, so that uh, when we go to the container registries, and so this is I purposefully make it, even the password is showing, and the everything is there, so it is uh, the available in the repo also, so you can have those things and make it implement while running your POC setup. So image scanning, we go to the container registry, so these are the things that we have in the under uh, the registry setting. And when we go to the scanning, uh, the EchoSec, and the other open third party integration that we have, so we can go to the Aqua portal and make a connection to the ACR container registries, and able to scan the registries, the images that we have in the Azure container registries.
Dixit,
Parth,
sorry to
do we
stop you
have any
there.
questions?
Yeah, yeah. Can you bit zoom in your screen? And also, we have a question. Yeah. So there is a question from Kiran.
Hmm.
What will be the best practice to migrate K8s workload from managed K8s and unmanaged K8s cluster to AKS workload?
So, Kiran, obviously, when we talked about the Kubernetes part, whether it is the managed part or whether it is the, you can say, the Kubernetes on a VM, obviously, it is the cloud agnostic approach. You already had it in one way or the other form, because you already have the images with you, you already have the YAML files, you already have those configurations available with you. So more or less, it is the cloud agnostic part that you have already come across when you move or taken your journey towards the containerization. But yes, obviously, when we talked about moving from one specific cloud provider to the another specific cloud providers, so there are configuration changes, but more or less, uh, it will be the same setup. For example, let's say, uh, if I'm deploying my application in the Azure, obviously I do have the my images into the ACR, and then deploy that YAML configurations for the deployment of the AKS clusters. So if I move on to the, or moving in to the Azure from the other cloud providers, I need to follow the same pattern. But yes, there are couple of things that we need to make sure that when I'm moving from unmanaged, or let's say the Kubernetes on a in a Docker hub kind of environment, so uh, or the mini cube, that environment that you have, again the same thing, almost 80 to 90%, as we have taken the journey of the containerization. So it is already the cloud agnostic approach, but yes, some changes with respect to the specific cloud providers, we need to make those. And also we do have certain public documentations available. At the end of the session, I will make sure that I will ping those uh, the documentation that will talked about how to make a move to the AKS from the other cloud providers. And if you're still having any doubts, uh, feel free to reach out to me or Parth, and from the or your account team, uh, and we are happy to have the detailed discussions around those. Parth, shall we move on? Any other questions in the chat window?
No, Dikshit, I don't see any other questions. We can go ahead.
Okay. So on the same lines, this is the portal, or the screenshot from the Aqua portal. So it made the connections with the Azure Container Registries by having the username and passwords and having that particular workflow, and they are able to and you are able to scan those images by using Aqua in the Azure Container Registry that we have. So in the ACI design, so as we are discussing that, obviously in the dev and the in the lower environments, living the prod environments, you can have those images, and those can be, you can say, uh, the mix of images that you can have. It can be of any it can be of any size, and obviously you are making frequent updates to those images. But the only recommendation that we have, and we have seen while working with many customers across the globe, is that while working on the while working with the prod environment, please make sure that you have uh, uh, the RBAC, the authentications, the authorizations in place, while while having the connections um, with the ACR, or the integrations available with the ACR and the AKS, so that only the prod AKS clusters will able to uh, pull images from the ACRs, and also have those proper RBAC configuration, that it will only be able to pull images rather than uh, access denied while somebody is trying to give somebody is trying to push images to the ACRs. So just make sure that we will have all those RBAC policies, the authentication and the authorization in place while having those integrations, especially for the prod environments. Again, coming to the Azure portal overview, as we discussed regarding the integrations of the ACR with the AKS, and the recommended and the best practices of using the managed identity, just wanted to give the portal view, that how it look when we have the container registry in the Azure portals, and where we do have the AKS managed identity. Coming to the integrations between the Azure AD and the Azure and the Kubernetes RBACs. So obviously, uh, Azure AD and the authentication or the integrations between AKS cluster, or let's say any service integration with the Azure AD. So as a developer, I will make a request, or uh, I will make a request to the Azure AD. The Azure AD will obviously give me that particular token, and that particular token will allow me to access that particular the resource and service which I'm able to uh, access in the Azure portal or in the Azure subscriptions. So first of all, Kubernetes RBAC is different, um, and when we are discussing about the Kubernetes RBAC, we are focusing more on the uh, operations or the resources within the Kubernetes clusters. And when we talked about Azure RBAC, we are discussing more on the uh, Azure subscription level and the resources within your Azure subscriptions. So one of the recommended practices that obviously there are some cool works going on, that we are able to have the managed identity, and we can able to give the uh, you can say the access to the resources from the Kubernetes cluster to the Azure load balancer to the managed to the Cosmos DB by the managed entity, and you will not be able to explicitly go and manage those secrets and rotate them. So one of the thing is that when we are authenticating to the AKS, obviously there are certain Kubernetes RBAC rules uh, that we need to follow to perform certain operations. For example, if I need to list down all the pods running in the Kubernetes cluster, if I need to list all the namespaces running in the Kubernetes, we need to have certain Kubernetes uh, uh, RBACs that we have. In addition to that, obviously, uh, if we are not a member of any of the admin group in the Azure AD, those permissions will you will only have the access to the Kubernetes clusters, but eventually you need certain uh, Kubernetes rules at the cluster level or at the namespace level, so that so that user or the group of users will able to perform certain action on those things. So you can be the part of Azure AD group, and then probably in between you can also be the part of the Azure AD admin group, so where the role binding permissions at the Kubernetes cluster will eventually come to you automatically, because we do have the integrations between the Azure AD and the AKS, and you will be able to perform those operations. But let's say if you're still looking for some more granular thing, then obviously you can create the custom rules and the custom RBAC to perform certain roles or actions according to your business requirement. Um, Same, more on the same line that what we have discussed. Eventually, the integrations mechanism or the integrations between the Azure AD and the Kubernetes RBAC and the Azure RBAC. So basically, it generally offload the work that or let's say the offload the manual work that we need to do, that we need to create separate roles and permissions for each user and the group of users. So if that particular user, if that particular group is already there in the Azure AD, if you are using uh, the AD part, the Azure AD part, then you can assign those uh, role based bindings and the other roles in in the AD itself, rather than having those rules specifically at the Kubernetes levels. Coming to the networking part, so in the AKS, we do have two basic networking options available. First is one is the KubeNet, and the other is one is the Azure CNI. KubeNet is the default node or the default networking option when you create the AKS clusters. Uh, Now we prefer Azure CNI over KubeNet, and reasons for that in the case of KubeNet, uh, when we are choosing the or we are when we are creating the AKS cluster with the KubeNet, the nodes will get the IP address from the subnet virtual address space, but the pods will get their IP addresses different from the uh, subnet logical address space. So in that particular sense, obviously there is a saving of those IP addresses, but eventually you need a NAT to reach those uh, uh, endpoints if you want to access them. On the other sides, in the case of Azure CNI, as it is the first class service from the Azure side, and uh, even the pods and the nodes both. I repeat, the pods and the nodes both will have their IP addresses from the subnet address space, and as the pods are also getting the IP addresses, you will be able to reach the pods directly if you want to access them. So as the pods are getting the IP addresses, there are no route tables, and hence uh, the performance will be better in the case of Azure CNI. But the downside is that you need to plan well before um, for the for the nodes and the number of pods that you are planning to run in the AKS cluster configurations. So well you need planning in terms of IP that you need uh, in terms of scalability also, and in terms of and also during the upgrade uh, process. So please make sure that whenever uh, you are using those networking options, the recommended practices go with the Azure CNI, but it needs a certain planning well in advance, so that whenever we go with the scale out operations, things will work as per your expectations. So for example, just quoting the one simple example, if I have the maximum pods per node is equal to 30, and if I have 1000 nodes, in the case of Azure CNI, just a rough number, not the exact thing, so that you get the brief idea about the number of IPs that you need in the case of Azure CNI. So 30 pods per node into 1000 nodes is equal to 30,000 IPs, because we have 30 pods and we do have 1000 nodes. So 30 into 1000, 30,000. On top of that, we have 1000 nodes. So as we are also getting IPs for the nodes as well, and IP for the pods as well, so 1000 IPs for the nodes. Now, as we have uh, we will also run the upgrades. So plus one node into 30 pods, and the other plus one node for the load balancer and the other stuff that we have. So in in a nutshell, or in a very baseline terms, if you have the if you are thinking of running 30 pods per node, and if you have 1000 nodes in the AKS clusters, then in terms of Azure CNI IP planning, what is the rough idea that you can think of while designing the AKS cluster with the Azure CNI? This slide is depicting those. Moving on to the network policy with Calico. Yes. So by default, um, all pods can
Hey,
communicate. Um,
Dixit, before we go on, there is one question
mhm.
from Drell. What is the best practice network segmentation available in K8S networking?
Parth, can you please come again?
What is the best practice network segmentation available in K8S networking?
So if the question is more about that, whether we go with the Kubernetes part or whether we go with the Azure CNI, as we discussed, so the recommended practice is to go with the Azure CNI, because there is no netting thing required in the Azure CNI, as we have the IPs available, as the IPs will be mapped directly to the pods and directly mapped to the nodes as well. So there is a performance improvement. But yes, the only thing that we need to make sure while designing or while going with the Azure CNI, please make sure that we will have the proper planning in terms of IP depth that we need, in terms of the scalability that we are looking from the future perspective, and also in terms of workloads that we are planning to run on those nodes. And in the case of network policies, again, we do have two Calico network policies and the Azure network policies, but the preferred approach in this particular case, and many customers who are using Go is and the many customers who are using is by the Calico network policies. Even we do have the first end policies, but the generally what we have seen and the recommended practice is to go with the Calico network policies. So again, to why do we need network policies? Obviously, I hope uh, we know, but we can discuss about that. Obviously, at when we create the AKS clusters, by default all ports can communicate. So to control the traffic ingress and the egress, uh, we can have certain policies to control those traffic and how they are communicating with each other, and how to make it more secure. For example, the backend pods or the backend service will only be able to accept request only from the front end, rather than accepting traffic from any other. service or the ports. So on those lines, these are the network policies that AKS has. But um, if you think about the networking modes, Azure CNI with the Calico network policies will be the recommended approach. I take a pause and then just let me know if I answer your question, or probably if there are any further questions from your side.
So meanwhile, there is a question from Kiran. Like, do you have an example for K8s RBAC versus Azure RBAC?
Yes. So for example, Kiran, when we say example, so for example, let's say in the case of as in the case of Kubernetes RBAC, so you can have those RBACs at the role level and at the role binding level. When we say role binding level, at the namespace level. So let's say at the cube in the Kubernetes clusters, I have created 15 namespaces, or let's say just hypothetically 10 namespaces. Now I need to make sure that Kiran will have access only to the 4 namespaces that we have created, and Dixit as a users will have access to the other 6 remaining namespaces. So in those terms, I can have those Kubernetes RBAC things at the role binding level, at the namespace level, which will make sure that Kiran will have access only to those 4, and Dikshit as a users will have access only to those 6.
So
Any other questions,
going
Parth?
ahead, yeah. So there is again question from Dral. How does these network policies differ from NSG?
Okay. Well, NSG is simply the, you can say the, uh, I can say, so under NSG RIL, what we are doing, we are creating, uh, let's say in a subnet, I have one particular service, or I will take a step back. Let's say in one particular VNets, I have created 3 subnets, right? Now NSGs are applied at the subnet levels for the inbound at the outbound. So what we are saying, I am applying NSG at the subnet, and I can only make sure that whatever traffic, whether in or whether out, I am controlling by applying the NSG at the subnet level. Now what we are saying, under those subnets, under those Kubernetes clusters, under those subnets, let's say under one particular subnets, you are running multiple pods. So NSG can be filtered or NSG can be applied at the subnet level, but what about the pod communication in between those? So I have 15, 30, 20, 10 pods running under one particular subnet. So if I want to control the traffic, or if I want to control the security between those pods running under one subnet, what is the networking options that we have in the Kubernetes clusters, is these are the policies. But the NSGs will only work at the subnet level. These worked at the more granular fashion when we talked about the Kubernetes clusters.
I hope that answers their question. Uh,
Sure. So let's
I think we
move
can
on.
move ahead. Yeah, yeah.
Sure. Yes. So on the same lines that we are discussing about the Azure network policies and the Calico network policies, obviously, what you can do as a user, or what you can do as a cloud solution architect, or as a uh, DevOps admin, you can probably enable it, and probably you can later it afterwards. But please make sure that you enable those network policies, so that in the future, or probably in the due course of time, whenever you want to use it, you already have that particular option enabled, and you will be able to use it whenever your requirement comes. The last thing that we have is regarding that. Obviously, we do have the AKS clusters. We do have the the AKS cluster deployed, running the application is running, uh, the container, the pods, the other application, the other uh, uh, compute based logs that we're looking for, how to view those logs. So from the Kubernetes cluster, from the Azure's uh, perspective, we do have the Azure monitor, and the we do have also have the container insights. But many customers also use other open source tools, for example, Prometheus, Grafana. So even those integrations are also available. Happy to uh, you can leverage or use anyone, but just wanted to showcase, or just wanted to have those views that even from the uh, Azure service side, if you want to view the CPU type, the metrics types, the other logs that are running, how well is my container running. um, so all those particular details can be well captured, and you can then probably have those queries running on those by leveraging Azure monitors and the container insights. So these are some of the portal screenshots uh, that you can uh, able to see that in the Kubernetes clusters. If I want to say enable the Azure monitors, uh, where do I need to click in the Azure portals and be able to enable those options for the Kubernetes clusters? With this, yes. So same thing. The basically the if you want to have the logging mechanism for the Kubernetes clusters and want to see the logs from the CPU metrics container perspective, what are the various options available in the from the Azure sites. So these are the quick review that we have gone through. We discussed about the baseline AKS configurations, about the compute and the infrastructure, the process side, the networking side, and the observability. Uh, and these are some of the resources that I will share in the chat window after this particular session. But yes, open for any Q&A that anybody might have it. And just to make the announcement, on probably Parth, please correct me if I'm wrong. I believe on 28th we do have another one sessions in which we are going to discuss about the KEDA and the uh, other offerings of the Kubernetes clusters. And in those we will also have uh, demo also. Yes, now open for Q&A.
Yes, we have session on 28th on
Okay,
Kena
sure.
and yep. So any more questions? Please drop all your questions in the chat. So meanwhile, I'd like to share the learn module link. So here is the learn module link. It will take your learning further. Okay, we have a question.
Mhm.
Have you got any reference architecture best practices for Azure Kubernetes services?
Yes, we do have it. We do have it. So uh, after the session, I will also make sure that I will put the baseline architecture as well, for sure. Or or probably if you want, we can also have a session probably in the month of March in the on the architecture itself from the Kubernetes perspective, if you want it. But yes, after the sessions, probably after a couple of minutes, we'll surely uh, share the baseline architecture of the Kubernetes perspective from the best recommendation practice.
Any more questions? Final call to ask the questions. Okay. So do you mind sharing Kubernetes workload migration best practices readables? Okay,
Yes, will do. Two things: migration thing and the AKS architecture baseline.
cool.
Please let us know if you need anything apart from these two.
Do you have those links handy, Dikshit?
Yes. So I need to probably then stop my sharing and then probably will share. Can I do it now, Parth?
Yeah.
Okay. Let me do it.
Welcome, Kiran.
Yes. So
Dikshit, I think your screen is off.
I'm just sharing the. I put it in the chat window regarding the baseline architecture.
Okay.
Give me 1 second more regarding the migration thing. Yes, here we
Yep.
go. The other one is migrating to the AKS cluster.
Cool.
Yes.
Okay. Okay. So both the links are in the comment section. Yep. 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 Okay. Okay. Any more questions? Folks, any more questions? Final call. I think we are good now. Dikshit, let's call for a wrap.
Sure, Parth. Sure.
Okay.
Uh,
Okay.
Thank you so much, Parth, and thanks everyone for joining in. But just one request: we do have a upcoming session on 28th as well, in which we are going to discuss about the CADA and the other things also, and we will also have demo on those. But again, one request: if you still feel that you need the other Kubernetes sessions on the architecture or any other Kubernetes topics, please put it in the comment sections, and me and Parth will work on those lines, and we'll also cover those sessions in the upcoming months, probably in the month of March itself. Thank you.
Sure. Sure. Thank you. Thank you, everyone. Thank you
Thanks
so much
everyone. Bye
for,
bye.
and have a nice day.
Thank you.